getting ready for our last set of talks. We hopefully kept the best for last to talk to us about adaptable UIs with QtQuick. Alan, please.
Thank you. Okay, so the key thing about this talk is it's not just the general Adaptable UI thing, it's also about all the new stuff that's coming in, because in Qt 5, Adaptable UI was a very simple story. If you wanted to deploy your application to something else, you wrote a new UI. There you go, just write on a completely separate UI, and that adapts it. But we have some better solutions that we're working on. I mean, that's a great start, but we've been doing so much more. So this talk is going to cover some of the new things in Qt 5.1 and 5.2 that make it easier to adapt your UIs. So first we will have to go over slightly what adaptable UI means, and then the 4 key things that I'm going to talk about on how to implement an adaptable UI are layouts, bindings, file selectors, and loaders. Layouts themselves are new in 5.1, and file selectors are new in 5.2. Some of the things being used with the bindings and loaders also tie into these, so even those have been improved in Qt 5.1 and Qt 5.2. And in case you think that 4 different things for adaptable UI is too much, I was reading an article recently which was titled 45 plus tools for adaptive design on the web. So the fact that we have 4 things that you get to learn instead of trying to match together 45 plus is a start. So what is adaptable UI? It's magic. It's the dream of trying to get your UI to adapt to where it is instead of you having to adapt it. And I think that this sentiment is best expressed with a song. To dream the impossible dream, to write adaptable UI, to run the same code on embedded, with no mouse and low DPI. We'll finish the song later if we have time, but thank you. But the main feeling that I want to convey is that the adaptable UI dream of this magic adaptation, it's as compelling and as depressingly unrealistic as Don Quixote's vision. So we can't provide you an automatically adapting UI. All we can do is make things easier for you, because that's what Qt does. It provides the tools to make it easier for you to write your UI. So let's have a look at some of the adaptable UI challenges that applications face that we really should make easier. The first is simply resizing. If you have a desktop window and you can resize it, you want the controls to use the space. You want to be able to spread the text out. You want to be able to shrink the buttons so they'll all still fit in. You want to just be able to react to the resizing of the window. And this is also the same adaptations you need when resizing the screen when you go from one device to another. And in the one device to another case, you may recognize these 2 stunningly handsome devices, the BlackBerry Z10 and the BlackBerry Q10. And there you need to adapt not only to the different resolution of the screen, but also the different form factor. The hardware keyboard on the Q10 takes up so much room that a good Q10 application is going to make use of it. It's going to want to move as much navigation as possible from buttons that take up valuable screen space into keyboard shortcuts that work so well with that beautiful hardware keyboard. And this is all adaptation you have to do despite the fact that it's running the same BlackBerry 10 operating system underneath. And a final example, which is not particularly well designed, is the case of moving from desktop to embedded. If you're moving a desktop UI to an embedded or mobile use case, you often will want to just change out some things for the embedded equivalent. An example is these checkboxes for settings. you might want to switch those to switches, which look and feel better on mobile and some embedded cases. And this is why the QtQuick controls in 5.2 are going to bring in some switches for you. But you still need to be able to have your application start using it when it's appropriate. And of course, the final example of where the UI might need to adapt from Nuno's excellent talk is when you're just going into a different system where the UI conventions are different. Maybe it's the exact same screen size, the exact same input mechanism, but it's going from Android to iOS, and you want to change things just so that it looks consistent and fits in with the rest of the platform. So the first thing you can use to help do things adaptively is the layouts. These are new in 5.1, and you import QtQuick.layout. And as you can see, this is very similar to the QML code a few slides back. This buttons and a text area is done with a simple QML code. You have a layout which has a size, and then it will position the elements inside it to try and use that size. This allows you to scale with window resize, as demonstrated, an important use case for desktop applications, and of course the screen resize, which is important when targeting multiple mobile or embedded devices. It also helps provide the maximum use of the space in order to keep from having the expansion and resizing just adding more dead space. And that means that it fits in well with some existing control sets when the controls change a little. The important thing is that this was cribbed from widgets. You will all recognize layouts from Qt4 widgets where it worked perfectly on desktop. I mean, we don't really need to reinvent the wheel here. The Qt widgets, the layout system there, it fit the desktop needs perfectly. So, we have that for your modern QML APIs. So that means that it's working well with controls and desktop UIs. But one thing to consider when choosing when to use layouts for adaptation, the desktop UIs are great, but not so good for the pixel-perfect designs. We didn't really see these on desktop during the Qt4 era. You wanted to fit in. You didn't want to have some crazy rectangles flowing all over the screen like modern UIs. So the layouts, it's very hard to have that precise control over the items. And so when you're using pixel-perfect designs, you'll probably need a different solution. The other concern to keep in mind with layouts is the performance cost. This is another reason why they're perfect for desktop. No one notices. You can resize, and it will recalculate all the time those sizes. And you've got the horsepower for it. No one will notice. But then on mobile, if you have an animation on an item with a layout growing larger, the mobile device might not have the power to smoothly relay out that object every single frame. And so on a lot of mobile embedded devices, you may need to be careful with your use of layouts to make sure that you don't run into performance problems. So that's how you can use layouts. Bindings is for those other cases. I did say there are some places where layouts aren't so great. You can always fall back to bindings. It covers any special cases. It works with continuous numbers, and you can always expose what you need from C++. Now, I could put this at the end of my talk and say, well, for everything not covered, use bindings. But I want to stress up front that this is one of the great strengths of QML. You have bindings. You can expose stuff from C++. Yeah, it's great when there's something there that makes it easier, when there's some tool like layouts that does your work for you. But it's even better, in my opinion, that when you run into a case, and you'll always run into these cases eventually, where we don't have a pre-made solution for you, in that case, you can write your own, and you can integrate it well with all the other solutions. So it's very important, I think, to consider any time that these adaptable UI approaches aren't working out for you. You don't need to scrap the whole UI. You can always just solve that specific case yourself using bindings and using whatever you need exposed from C++. A good example being that if you need to respond to pixel density, a continuous number, in a more custom way than the buckets provided by the platform, you can. In fact, we expose the logical pixel density of the screen the item's currently on the off the screen attached item as of 5.1, I believe. So if you want to deal with really low DPI, especially, you can do that with this complex source binding. Same with the ultra high DPI. You can do whatever specific use case you need can probably be done with bindings, and then that solves that problem whilst not requiring you to re-architect your entire UI or entire application. Another example, which is not adapted to fit the screen size, is the case of having a special flag in the app logic, and that's just you exposed a flag from your own application. It's not automatically coming with QtQuick, but you have the C++ part that knows, in this case, we want to do this, and then it can expose that to QML, and you can just use a binding there. So it's great for dynamic things, it's great for continuous numbers, and it's great whenever nothing else works, but there are reasons why you wouldn't use them all the time. There are reasons why the pre-made solutions can be better. And the main one is that bindings can have a relatively high performance cost. If you have bindings everywhere, then you're evaluating bits of JavaScript everywhere, and every time something related to that changes. Now, it's the death of 1,000 cuts problem. An individual binding isn't really that expensive, but when you create a UI composed of so many bindings, then the cost does add up, and a binding will never be as fast or as efficient as just having in a fixed pixel value. So you do have to watch out with overusing them. And of course, one thing that I didn't put on the slide is that bindings can be a little uglier. The layout code, if we go back and look at that, that is beautiful. I mean, just perfectly clear. The bindings, however, for an image source, that's not quite so good. You can see it's a bit big for a source binding. It's shoving in a JavaScript log. It's not as readable. And so that's one of the compromises you take when falling back to bindings. So the next thing that you can use, new in 5.2, are file selectors. Can anyone spot the file selectors in this example? I thought not. It's because file selectors are designed to be transparent, to slot in there without you really having to design for them up front. When loading types like myButton, or when loading URLs like button.png, you can provide an alternative asset or an alternative type, which will then get selected. And the nice thing about making it so transparent is that then you can start adding new variants when you port to a new device, and you don't have to start explicitly creating the app version for the device. You can recompile for your new target. You can put that on the device, and then at runtime you can start swapping out individual assets one by one without having an expensive deployment step. So let's say that these are the files that were in that directory. There's a main.qml that we were looking at. There's the myButton.qml providing the myButton type. And of course, there's the button.png that was referenced. We can have these selectors, the plus BlackBerry. Selectors are done using a plus sign in the selector name so as not to conflict with genuine folders. In this case, when you ask for button.png and you're on BlackBerry, the platform, it will select that other button.png. And likewise, when you're on the Android platform, it will select the myButton.qml when trying to create a myButton type. So you can automatically swap out the myButton on Android using file selectors, and it doesn't make your code look ugly. So this is maybe looks similar to some people to the DPI buckets that you'll find for image assets on, say, Android, where it will automatically pick up a 2x image or a low DPI image based on the specific device. But this is generalized far beyond DPI. And it's generalized beyond assets. As you see, you can select types. You can select any URL. It will adapt anything that you need. In fact, these selectors can also be determined from C++, so it can also select based on custom application requirements. In a way, it's kind of like ifdef, especially with the new singleton functionality. So previously, you might have had a C++ where code which had ifdef QoS Android QQML component this file, ifdef QoS BlackBerry QQML component this file. This provides a much nicer way of doing it, which is also inside QML. You don't have to pop down to C++ just to choose a different URL or access the platform. Unlike ifdefs, it's not quite as ugly, arbitrary, and confusing. So this is just file selection. You can't define the plus symbol to mean something else. You can't clutter your code with just a huge section of ifdefs, which you then have to manually pre-process when you're reading it. It's a lot nicer for this very specific use case and keeps the QML code actually readable while still giving it some of the powers that you had in C++ using ifdefs. So here's an example of the new singleton API, which, as I said, works great with the file selectors. We have pragma singleton, and then we have an object with some properties. And then the whole point of a QML singleton is that this object, when you try and access the type, you access a single instance of this object for each engine. So that means that you don't have to, you can access it from everywhere, and you don't create tons of instances. You just have one instance with these properties, whatever bindings or details you need. And the big advantage of this comes in when you combine it with selectors. So if you have a rectangle like this, great, you can access the color and center margins from a centralized place. That's a little nicer. But if those are UI constants that should vary in a particular situation, like on a certain device or on a certain platform, then the QML file defining that singleton can be selected. You can have a plus BlackBerry myvalues.qml with a different, which is still a singleton, but has different values for those properties. And then that will automatically get selected so that the color will be the color you want on BlackBerry. So file selectors are great for the asset swapping for different DPIs or different platforms. And they're great for UI constants when used with singletons. So here's some cases where you can really simplify your UI adaptation by just swapping bits out like this. But there are some limitations. It's not currently good for dynamic use cases. That's a research project that hopefully we'll get in by 5.3. So this is for static cases. This is for cases where you start up your application and you know, I have this DPI, I have this device, I have this platform, and then you create your QML scene. You can't quite react to like the DPI changing if you plug in a different screen, or the resolution changing if you resize the window. File selectors can't currently handle that. And also it requires a specific file structure. You need that plus BlackBerry folder containing the BlackBerry asset. So on to loaders. Again, like bindings, this is more about a fallback option. But you have some more complex options, and this is a fallback for when the file selectors aren't good enough. Because I quite like the idea of being able to swap out just a component. Because when you're switching from one platform to another or from embedded to desktop, it might be the general application flow is correct, that some of your custom widgets, you still want to use them, but there are certain bits that you want to swap out. You want to, this part of the options, which is currently a text checkbox component, swap that out for a text switch component. It might be that this central custom layout I'm using, there should be a different layout on the mobile, but you just want to swap out that particular part so that the rest of the code stays the same for maintainability. And by the same, I mean the same files, not a separate branch that was copy and pasted. So loaders allow you to do that in the cases where the file selectors don't currently support it, because the loaders are much more dynamic. And again, we're researching more interaction between the two. But here's an example for a more dynamic use case. If you want to add NFC UI on certain devices, but others won't have NFC, you can have a loader which will try and load your NFC UI, and that NFC UI will try and use NFC, but that might not work. The import might be missing. There might be some other problem. And then you can dynamically react to that. Instead of where the NFC UI might normally be, you can instead have some text saying that it's not available. You can have it not there. You can use bindings to just relay out your UI so that space never existed. This allows you to dynamically react to stimulus that might make you want to change your UI. The problem is that the code is uglier. This entire segment here, if we knew that there would always be some NFC UI available, we just had to select which one based on device, it would just be NFC UI open brace, close brace. It would be a lot simpler. Having to explicitly put this logic in there with bindings does make it a little uglier than using file selectors. So let's have a look at an example. And the example is, of course, going to be same game. Because that's not just the example I always use, but because the example I always use, I'm always trying to put it on different devices. Every time I get a new device to develop for, I put same game on it, and there are problems. Because just putting the same UI on another device, it doesn't always work. So I'm sure everyone's familiar with same game. I don't need to get a new high score in order to demonstrate. But one of the implementation details is that these blocks are defined in pixel sizes. And that means that when the DPI of the device changes, the blocks aren't always going to be a good size for the game. And I tried once binding to the DPI as a multiplier, but that doesn't work. Because what happens then is that you'll get space on the side where there's not enough room for a block. And it just looks terrible. So it needs to have a human go through and say, what's a good size for the blocks here? So we get a good number of blocks so that they're actually interactable easily. And so that it fits exactly with the header and the footer. I really can do better than that high score. It's a shame we don't have time. So now we might want to use selectors. And so we have, let's try using Kate. There's this settings singleton here. You might recognize from the example, it has a bunch of UI properties. So the header and footer size are extended to make them fit better on the higher DPI BlackBerry. The block size, of course, changes so that there's a reasonable number of touchable blocks on screen. And so when these UI constants are used inside the game files, they reference a singleton, and on BlackBerry, it will instead use not content settings, but content plus BlackBerry settings. And there you go. Another interesting thing for this example, you might notice that setting object is a little simple. What happened was that because the Q10 and the Z10 are similar in many ways, I used the QML componentization to have this bbsettings.qml with the BlackBerry settings. And then for it has the correct things for the Z10. And then for the Q10, which has its own separate set of selections, it has the things that it needs to change from the specific BlackBerry settings. And then I don't have to duplicate any UI constants which are the same on all BlackBerry, just because a couple of them should be different for Q10. So to test this with the file selectors, we can just use Qt file selectors environment variable. And then it will run with the BlackBerry file selectors. And you can see it's a lot bigger. The resolution of this projector, not good. The resolution of the Z10, really good. So this allows you to see pixel for pixel what it is. And in places like the Qt Creative Simulator, you might have it be actually shrunk down so as to look more reasonably sized because of the massive DPI difference. But sometimes you do want to look at that specific pixel per pixel thing, and then you'll see that the blocks are much bigger here. Because if you had the small blocks, it wouldn't be touchable. They wouldn't fit the right number. There would be some stuff on the edges. This is same game for Z10. And then we can also do the same for Q10. We just uncomment these. And run it for Q10. So you can see now it has a square screen with the sort of same pixel size. As you can tell, the Q10 also has a much better DPI than this projector. And the blocks, again, it's a different size, and I didn't do the constants right. You can see that ugly thing that can happen. But it has been properly adapted to fit the smaller, more square Q10 screen. And also, another small thing to point out, it may not be great, but these menu entries, because they're in a layout, they just automatically space themselves out there. They're images, so they don't really scale like buttons can. But it still provides just a basic level of adaptability that could then be improved upon when I get the new graphical assets for high DPI. So that's a quick example of some UI adaptability with the new singletons and selectors that allows same game to actually be adaptable. Beforehand, you had something like this. You had these UI constants, but they were in a JavaScript file that you had to manually edit each time you wanted to deploy to another device. So this way you can actually run same game on a variety of devices without having to edit the QML each time. And that has made things easier for me. So, I shouldn't have quit that. So to summarize, we'll go through it really fast. Oh, that's the one. So there are all these different ways that we try to make UI adaptability easier for you. But in the end, only you can prevent bad UIs. You have layouts for the UI problems that face desktop windows that allow you to resize the window for whatever resolution and whatever drag handles they want. You have bindings and C++ as the ultimate fallback, which is always available in case any of these don't work. So whenever we say there's limitations, we mean that you don't get to take an easy path. You just get to do it, still without having to rewrite your entire UI. It's still possible. We just haven't given you a shortcut. There are file selectors for a lot of cases of asset and type selection so that you can make your UI use switches on mobile and checkboxes on desktop so that you can use your higher DPI assets when you have a good phone and your lower DPI assets for these projectors. And of course, for any more dynamic type selection, there are always loaders, which you can combine with bindings in order to do a lot of dynamic choices on what components to use for certain parts of your UI. And the best part is that combining all of these things allows you to still make pixel-perfect UIs. Even if some parts you can afford to scale, like the buttons, those can take up whatever space you might need. Anything that needs to be pixel-perfect, those parts still can be while you swap out anything else. You can conserve that value that QtQuick provides of ultimate control over your user interface in whatever parts need it, while still using some of these shortcuts for any part which either doesn't need pixel-perfect UI or which maintains perfect UI, such as swapping out some elements of the same size. And that is the end of this presentation. If anyone has questions or song requests, I believe we're now open for them.
Thank you. How does this work with tooling? How does tooling know which file selectors are active?
I don't know. You'd have to ask the tooling guys. The better answer is that
I can answer that.
is that he can tell you.
Actually, in 3.0, there will be some initial thing to be able to select that will be developed then in the next release. But basically, you can choose for the editor and for the designer the selectors, the active selectors, and switch them.
A question about your different files for BlackBerry and for Android and for Q10. Why are not you? I saw that you always set up the high and the wide of the devices. Is it not possible if I turn the program in full screen that I get the size and the high of the device?
That is correct. You can. This is a specific quirk of same game. Due for legacy reasons, how it was written leaves the window control on the C++ side, and modern QML applications I would recommend to have the window control in QML by using a window element. And in that way, not only will you be able to alter the size more dynamically, but it can say size full screen in your QML. And yeah, so that's just same game. If you write your application with the modern patterns for QML applications, then you will get that.
Okay, so there are a few things that I was missing from your presentation, or might be missing from Qt. So first there is the QML states. So I was thinking, is that a technique that could be used for adaptable UIs? And other things missing is, if you compare to Android, there is the density independent pixels, Ubuntu has the grid units, and so on. So and also vector graphics as a way of creating adaptable UI. So what's your comments on these things?
All right, so for states are not for adaptable UI in the same sense. States are for when the UI is adapting purely to runtime changes. Like when you rotate the phone and it goes from portrait to landscape. That's something that's done very well using states. But that's not adapting your UI to a different device or a different form factor. That's a much more dynamic use case. So states work great for some things that are a little adaptive, but it's not going to work for bringing your application from one device to another or from one platform to another. So perhaps I should have defined adaptable UI a little more strictly. The second, as for the density independent pixels, the thing there is that once you start using those, you have ruined the pixel perfect part. You no longer know what it will look like really on that device, and if you do, you may as well just use pixel values. So if you're going to be adapting for specific devices, you can use specific pixel values which are adapted. You can use bindings to the DPI, which you know will work on those specific devices. And all that pixel units really add in the current implementation will be additional performance overhead. They're going to be as expensive as a binding to DPI, whether you realize it or not. So we would prefer that people use just straight pixel values and save that cost. And the third thing was SVGs and vector graphics. So those are supported in that you can give an image an SVG source and it will render that. And that's fine, it will scale it and such. But the thing is that comes with such performance problems that generally I would recommend rasterizing to the sizes you want, and then you can still just apply a scale transform when you resize that image. The thing is that as much as it sounds like it solves all the problems, SVG does not. I use KDE, and sometimes I make this bottom bar really big, and those are SVG icons, I believe. Yet, I don't know. I just don't think it's better than if they did raster scaling, but all right, I think they're better than if they did a raster scaling, but that's still not correct. So Yeah, you don't want to think, oh, I'll just use SVG and then it will work, the answers. I'm pretty sure that's a bug in KDE. So, yeah, SVGs are not actually going to help that much, so I don't include them in my recommendations for adaptive UIs. And I'm pretty sure that's everything you asked. Okay.
If I put my QML files into the resource system, is there a kind of a filter in the resource compiler so that I don't have to ship all my resources that are not needed for a platform on every platform?
No, we do not currently have that functionality. Now, if you're going through the resource system anyway, one thing that you can do is you can have a different resources file which maps different files to the same resource path. And that's basically another implementation of the file selectors for some specific cases. It gives you the same effect, but faster. So you can sort of do your own custom selection to get that extra performance edge in that case. But that case is somewhat limited. You need to be able to alter the resource file, and you need to know what you're running on at compile time. So there are drawbacks to that, and it's a lot more work because you have to manually maintain those QRC files. So yeah, some automatic file selection, resource integration would be nice in the longer term. We don't have that yet, and there's that workaround if you need the performance.
One question concerning text sizes. So you can give it in points or pixels.
Yeah.
The point information is something like DP in Android, but I found out doesn't work because the calculation from whatever is given in physical pixel to the point sizes in text information is not yet done. So if you calculate, if you give the text size in points, then you have to calculate with respect to your physical information of the screen sizes and DPI, the pixel size of the text.
Yes, we cannot return the pixel size if you use a point size. If you need that, you're going to have to set a pixel size by binding some multiplier to the DPI so as to manually perform that conversion. I've heard of some Android-specific problems with point size, and I believe that bindings using DPI are the workaround for that as well.
But this will work in 5.2?
I don't know. I haven't been testing on Android.
Because this is a major issue if you try to do an adaptable UI and the text size will scale depending on the DPI.
Well, if you don't want your text size to scale depending on the DPI, that's what pixel size is for. And most of our examples use pixel sizes. If you want it to scale based on the DPI, then all I can say is Android should fix their point size. There are mobile platforms that work.
A question from someone who didn't get hands-on with QML yet. How well does the device detection work? So can, if I'm writing something for Android version 2, a different thing for BlackBerry, and how well does the version detection, especially with minor differences, work?
So the version detection that comes for the file selectors that comes with Qt is basically the stuff that Qt knows and exposes through the ifdefs. So you get which platform the same exactly as you would using ifdef QoS, and that only goes to the granularity of Android or BlackBerry. If you need more details, then you'll need to expose it yourself, and details that are more sort of platform specific that Qt might not know about generically, like Android API levels or Q10 versus Z10. Those aren't being exposed automatically. You'll need to either add those selectors in your own application, or the platform will need to provide them. You can add selectors using a C++ API or through environment variables, so it is quite easy if you know that, but through some C++ API function, that this is Android level 2, you can add an Android level 2 selector.
Hi, I have a question about internationalization. That's also you have also to adapt like a German string or the same text in English. So what's your in your opinion the best way to deal with this in QML?
Again, this is a much more dynamic case than I was originally thinking of, but a lot of the problems can be solved in the same way. The problems that you traditionally have with German strings of them being way too long and not fitting, that I believe is covered with layouts. They can just give you more room for the text when you need it, but it will ruin your pixel perfect UI. There's not so much you can do about that. There are selectors for locale in case you need to actually make a change, like make the menu bar 2 levels on German because they just need that much space for their words. That can be done, but for the most part, you're going to have the same thing as widgets where text can resize when necessary due to layout, and the rest of the time it just doesn't look so great internationalized.
I have another question to SVG, because I use it often for my application, not in QML, but in Qt widgets with QGraphics view and something. And for me, it really works quite well, not as bad as here. And the next thing is you said that it costs a lot of performance, but I only have to do it one time at the startup. So I can let some seconds to scale all my graphics and then show it up. So it would be a good opportunity if I have a really huge screen or a really small screen.
Startup time is performance, so you really do need to be careful about that. But yes, if SVGs work for you, then they are supported in QtQuick. You can have an image with a specified source size of what size you want the SVG rendered to, and an SVG source, and then it will load that SVG file once on startup, and you'll get that. So if it works for you, you can use it. We have the same SVG tiny support as QtWidgets does. But I'm surprised that it works for you. I'd have to look into your use case more to know if it works for you because the designer hasn't looked at it, or if it works for you because you're really good.
Can I add a little bit into SVG? I've been doing SVG for the last 12 years or something. The definition, it's scalable vector graphics, but really scalable. As in, if you want your 1 pixel borderline, once you scale it, it's no longer 1 pixel, right? So it works in the mathematical sense, but it doesn't work like a border image, for example, works, which is something that you probably want more in doing scalable graphics on the computer screen. We want your button to scale and that the border remains 1 pixel across across the same DPI area, and then maybe you need different assets depending on ranges of DPIs. Any more questions? No? Just one last one.
Those aren't SVGs.
Is it possible to override a file selector to take a custom control about some finer asset loadings? That means if I am not fully satisfied with a lot of selectors and have some corner case, then I exactly know which file I want to load. Is it possible to override file selector functionality, customize it somehow?
That is one of the things being looked into for the more advanced and dynamic file selector functionality later. So having more fine-grained control in QML is something that we want to do. One thing I forgot to mention is that when I say file selectors are automatically applied, it's actually not like baked into the QML language. It's just something that you'll probably be using. So you might notice that I'm using the awesome new QML runtime, not a QML scene or some C++ shell, because that uses QQML application engine. And one of the conveniences that QQML application provides is that it sets up file selectors for you. They're not part of a standard QQML engine. You can provide your own custom file selectors from C++. You can go without file selectors from C++. You can even disable them on a QQML application engine if you want to. But QQML application engine will, by default, set up file selectors so that you can use them transparently. So yeah, not in QML just yet.
Okay, so This is the end. Please, a last round of applause for Alan.